Hey physics people, welcome to another dynamics physics problem. This one on Newton's laws with kinematics. A particular race car can cover a quarter-mile track 402 meters in 5.60 seconds from a standstill. Assuming the acceleration is constant, how many G's does the driver experience? If the combined mass of the driver and race car is 458 kilograms, what horizontal force must the road exert on the tires? So we're looking here for both an acceleration and a force. Okay, so for the first part, to determine the acceleration, let's first look at what we're given. Okay, so the race car starts from a standstill. So I'm going to assume that the initial position x0 is 0 meters. Okay. The person in the car is covering a quarter-mile track, 402 meters. So I'm going to let that be x. X is equal to 402, pardon me. It's funny, I say 402, but I write 420. Okay, here we go. 402 meters. The time it takes is 5.60 seconds. Now, it says the car starts from a standstill. That implies that the initial speed is 0. So V0 is equal to 0 meters per second. And the last piece of information we're given is the combined mass of the driver and the car, which is, pardon me, 458 kilograms. Now, the question then becomes, how do we use these variables, or these given quantities, to determine the acceleration? Okay, so hopefully the first four combined gives you a familiar equation to use in this case that also involves acceleration, okay, and that is this kinematics formula. The delta x equals v0 t plus 1/2 acceleration times squared. Okay, so delta x is simply final minus initial position, x minus x0, v0 t plus 1/2 at squared. Okay, so there's a couple things in this equation we can cancel out. So v0 is 0, so this entire product disappears, and we also established that x0 is 0, so that also goes away. So then we're left with x equals 1/2 acceleration times squared. We are trying to find acceleration, so reorganizing this formula for acceleration, multiply both sides by 2, divide both sides by t squared, and you will get a is equal to 2x over t squared. Okay, so let's plug those in. So 2 times 402 meters divided by time squared, 5.60 seconds, so 2. And when you calculate this value out, you are going to get acceleration equals 25.6 meters per second squared. Okay, so that's not quite yet our answer, right? Because the question's asking us, how many G's does the driver experience? So a G is 9.8 meters per second squared, right? That's one factor of the acceleration due to gravity. So if we want to know how many G's there are, we simply take our acceleration, 25.6, and we divide it by 1 G, which is 9.8, and you get approximately 9.62. Okay, so therefore we can say the driver experiences 9.62 G's. And that is your answer for the first part. Okay, now for the next part, we have to find the horizontal force the road exerts on the tires. Okay, so let's do that next. Okay, so because we found acceleration and now we're dealing with force, I'm going to go ahead and draw a free body diagram, always an important part of any problem with Newton's laws. Okay, so we've got our road, we've got our race car, which ironically looks like our regular sedan from the previous video. Okay, we've got the normal force going up, we've got the gravitational force going down, we've got an accelerating force, Fa, going forward. So we have to define our positive directions. So let positive be up and to the right. Now again, in the vertical direction, the net force is 0. There's no acceleration, so Fn equals Fg, so we're not going to concern ourselves with the vertical direction. We are only concerned with the horizontal direction with that accelerating force. Okay, so in the x direction, F net x equals max. Okay, keep your vector symbols. We only have one vector in the x direction, and that's in the positive direction as per our definition. So f net x is equal to fa, drop that vector symbol, it's positive, equals max. That ax that I'm referring to here, that's the acceleration we just derived and found out in the first part, 25.6 meters per second squared. Okay, because that is, after all, the horizontal acceleration. So the mass, 458 kilograms times 25.6 meters per second squared, and you end up with 1.17 times 10 to the 4 newtons. Okay, so that is the horizontal force that the road must exert on the tires in order for the car to finish that track in 5.60 seconds. Okay, so that's it for this video, guys. If you enjoyed it, be sure to click that like button and subscribe to Physics in the Flash so you never miss a video from me. It's been a pleasure, guys. I hope you guys enjoy the rest of your day.